Very good morning to everyone. Today, we are continuing the yesterday's learning, what we have learned yesterday. One of the most important problem for 7 marks, yesterday we have in the last class completed. Moving towards that expected problem for the 7 marks, one more problem similar to yesterday's solution. Today, I am giving you as homework. Please try, and then we will move to the next topic. Till now, what we have dealt is about the question number 18 that will going to become in your exam. After giving the homework, we will go to the question number 19, expected 19th problem, what will become in your IP exam. Okay, so just first I'm going to write the homework problem for yesterday's concept, related to the yesterday's concept, and then we will move to the next concept. Okay. Please write this problem as homework. Find the equation of a circle. Equation of a circle. Find the equation of a circle which passes through 4, 1, 6, 5 and having center and having center on 4x plus 3y minus 24 is equal to 0. This is the problem similar to the yesterday's problem. Please note it down. If unable to see, listen my voice. Find the equation of a circle which passes through 4, 1, 6, 5 and having center on 4x plus 3y minus 24 is equal to 0. This is the problem related to the yesterday's last problem. Please solve it as a homework. Now, we will move to the, till now, how many problems we have solved for the question number 18 of your IP, section C, question number 18. Now, we will move to the what will come on question number 19 in your IP paper. Okay. Today we are going to learn transfer common tangent problem or direct common tangent problem. Okay. Just copy the problem with me and then we will go to the solution. Find the direct common tangents. Direct common tangents of the circles x square plus y square plus 22x minus 4y minus 100 is equal to 0 and x square plus y square minus 22x plus 4y plus 100 is equal to 0. कोई व्यूज है क्या देखिए, कोई व्यूज है क्या देखिए, कमेंट्स है क्या? हाँ ठीक है. Look at here on the board what is given to us and what we have to find. Okay, the first thing it is given that find the direct common tangents. Okay, I will tell you what is the meaning of direct common tangent. Of the circles, two equation of circles are given to us. Then we need to find direct equation of direct common tangents. First, we will understand what is direct common tangent. Okay, look at here. Before solving that solution, just I'm giving little bit introduction to direct common tangent and transfer common tangent. So it will be more easy for you to understand this solution. As a basics, I'm giving this. Here, for example, we are having a circle. Okay, for this, for the first equation of circle, imagine this is the circle, and we are having another circles, maybe of radius equal or radius less than compared to the first radius. Okay, these two circles are away from each other. Somewhere outside this circle, there is a point. There is a point. If I draw a line like this, okay, this is a line. Again, from here also I can draw. Okay, this point P of x comma y is called as external center of similitude. What is called? External center of similitude. See here, from this point, when we draw a line, this touches circles C1 and C2 at one place. Okay, these two circles are different, but the tangent is common. If a line touches the circle at one point, it is called as a tangent. That is the definition of tangent. Here, direct common tangent means from one external point, you are having two circles, but the tangent is one. This is called as direct common tangent. What is called this? Direct common tangent. This is called point of contact, and this also called point of contact. This point of contact, if I draw, this is the radius. Okay, radius is always perpendicular to point of contact. Okay, remember this. This is the small introduction about direct common tangent. Okay. Shall I rough? Then we are having transfer common tangent. Transfer common tangent, for example, take this two. In direct common tangent, point of similitude is external. Remember that. For example, we are having a point here. Okay. If I draw a line like this, and one more. Okay. This is an internal point between the circles, and the tangents that I have drawn from these two circles are called as transverse common tangent. Okay. This is the concept that we have to, and this is called internal point of similitude. If the point is lies between the circles, internal point of similitude. If it's outside from the circle or away from the circles, are called as external point of similitude. Remember it. Now we will come to the our page number 73 of your textbook. More details are given to you. Okay. To save the time, I have to solve the problem. And then if you want more and more details, please go to the page number 73 of your textbook 2B. Now, find the direct common tangents of the circles x square plus y square plus 22x minus 4y minus 100 is equal to 0, and x square plus y square minus 22x plus 4y plus 100 is equal to 0. First, the first step of the solution, you always have to start with solution. Given that, what is given to us? The first circle equation we represent with S1 is equal to x square plus y square plus 22x minus 4y minus 100 is equal to 0. Okay. And we are having another equation of circle. S2 is equal to x square plus y square minus 22x plus 4y plus 100 is equal to 0. These two equations of circle are given to us. Now, what is the next step? See here, first we will take the general equation of circle, that is, let S is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay. Now, comparing S1 and S2, you can write S1 is equal to 0 and S2 also is equal to 0. S1 is equal to 0 and S2 is equal to 0 with the general equation of circle. With the general equation of circles. Okay, that is h is equal to 0. You can write if you want to write. See here, 2gx, x square, y square, x square, y square as it is, 2gx. This 2g I can compare with 22, right? So 2g is equal to 22. 2f is equal to minus 4 and c is equal to minus 100. Okay. Now 2 1 the 2 11 the get cancel, 2 1 the 2 2 the get cancel. What we are having now, g is equal to 11, f is equal to minus 2. We are finding the center for the first circle, so we represent this as c1 minus g comma minus f. This is the formula for the center of a circle, that is minus g and minus f. So this is equal to minus 11 minus into minus plus 2. We got the first center for the first circle. Okay. Then radius r1 is equal to, this is the formula for the radius, g square plus f square minus c. Formula for the radius. Here I have written r1 for the circle first. Okay. So what is g square? So r1 is equal to, g square means 11 square plus f square. What is f? Minus 2 square minus c, minus into minus plus, so it will be plus 100. So this you can write, what is 11 square? 121 minus 2 square is 4 plus 100. This is nothing but 225, and the square root of 225 is 15. So we have got radius for the first circle as 15. Now comparing the same concept for the second circle. Okay, what we are getting? For S2 is equal to 0. 2G is equal to minus 22, comma, 2F is equal to 4, C is equal to 100. Okay. So 2 1 the, 2 11 the get cancel, 2 1 the, 2 2 the get cancel. So G is equal to minus 11, F is equal to 2, C is equal to 100. No need to write again. Okay. So center, that is C2 for the second circle, minus G comma minus F is equal to 11 comma minus 2. Okay. Now we will find R2, that is R2 is equal to G square plus F square minus C, that is root over G square. G square means 11 square. Okay. Center 2 minus G comma minus F. Center 1 minus 11 comma 2. Just little bit rectification. Okay. That's all. Now coming to this one, 11 square plus minus 2 square minus C. What is minus C? That is minus 100. Simplify it. If we simplify, let's see what we are getting. That is root over 121 plus 4 minus 100. This is equal to 121 plus 4, 125 minus 100. This is equal to 25. This is equal to 5. This is the value of R2. Okay. Finally, we have got C1, R1, C2, and R2. Now, what is the concept for the direct common tangents? So this is the concept we have begun. Now, the next thing, just I'm writing here, we will going to use afterwards. R1 plus R2 is equal to, what is the value of R1? 15 plus 5. This is equal to 20. Okay. Now we will find the distance between C1 and C2 is equal to root over, what is the formula of distance between any 2 points? If anyone don't know, so this is the formula, x2 minus x1 square plus y2 minus y1 square. C1 x1 y1, C2 x2 y2. So where is our C2? Yeah, x2 minus into minus plus x1 whole square, that is root over 11 plus 11 square. Y2 minus y1. What is y2? Minus 2 whole square. Minus 2 whole square. So this is nothing but 11 plus 11, 22 square minus 4 square. What is the 22 square? I think 484. Okay. So this you can write root over 484 minus 4 square is 16. So this is equal to 500. This 500 I can write 100 into 5. So this you can write 10 root 5. This is C1 and C2. Here R1 plus R2 is 20 and C1 into C2 is 10 root 5. If you multiply 10 with root 5, that is 2.236, the value of root 5. So this value will be big compared to this value. If this condition satisfy, we have what we have. Let's see on the board. So since C1, C2 greater than R1 plus R2. Okay, this means that the geometrical representation for this I'm writing here. Look at here. For this particular condition, for example, this is your circle, center one for the first circle. and this is the center 2 for the second circle. Okay. And here is the point of similitude, and these are the direct common tangents. Okay. These are the direct common tangents. Okay. C1, C2 greater than R1 plus R2. It means that two circles are away from each other. They are away from each other. This P of X comma Y is the external point of similitude. What is a similitude? I have explained before beginning this solution. So here, this condition satisfied means two circles are away from each other. Okay. Now, this point of similitude, from where the tangents are originated for the direct common tangents are originated for the circles, this point P of X comma Y. Okay. What does it's doing? Look at here. Let P of X comma Y divides C1 and C2 in the ratio. What is the first radius? 15. Second radius is 5. First radius is 15. Second radius is 5. Externally, this point lies external to the circle. So externally, 5 3 the 5 1 the. So finally you will get here 3:1. Okay. R1 is to R2. If you simplify, you will get 3:1 externally. You want to write here, or you can write here also, not an issue. But it's come from by the comparison of the radius. Okay, for the two circles externally. Okay. Now we have to use the section formula, that is P of X comma Y is equal to, this is the section formula, mx2 minus nx1 by m minus n comma my2 minus ny1 by m minus n. Okay. This is your m, this is your n. C1, x1, y1, C2 value is x2 and y2. So, according to the formula, what we are having, m x2. What is m? 3 x2. Where is my C2? Just we will write in the boxes. So, this is C1. Okay. Where is C2? This is C2. Okay. So, x2. What is x2? 11. So, this is 3 into 11 minus nx1. N is 1. X1. X1 value is minus 11 by m minus n. This is your m, this is your n. 3 minus 1, comma, m y2. M is 3, y2. Y2 is minus 2. Minus n is 1, y1. What is y1? 2. Again, by 3 m minus n, 3 minus 1. Okay, simplify it. 3 11 the 33, minus into minus, plus 1 11 the 11. 3 minus 1 is 2, minus 6, minus 2. So, by 2. What we are getting? 33 plus 11, 44. By 2, minus 8 by 2. Cancel 22, 2 to the 2 to the 2 1 the 2 4 the 2 1 the. So you are getting as 22 comma minus 4. So we have got external point of similitude by using the second formula here 22 comma minus 4. Finally, we have got, look at from the beginning what we have solved here. Have any doubt? Ask in the comment box before referring this. Just go through once, then we have to move forward. It is a lengthy problem, but the concept, general concept is same for the remaining problem also. So once you practice, the remaining problem automatically will be easy for you. So please go through once. Am I audible?
Yes, sir.
Okay. Have you seen the solution from the beginning? Have you understand each and every step from the beginning?
Yes, sir.
Yeah, see, this is the lengthy solution, but easy. So once again, I am asking if I have any doubt, please stop me there so I can clarify and we will forward. So just I'm referring here. This is the most expected problem will be on question number 19 in your coming IP exam. I need to use to get the previous equations for the next purpose. Now listen, we have got this point 22 comma minus 4. Okay, see here, this is external point of similitude and these are the circle and this is equation tangent. Okay, I'm taking, let m be the slope for, let m be the slope of tangent for the circle. Okay, so just here I'm writing what I'm going to use. Let m be the slope of the direct common tangents of the direct common tangents. Okay, m is the slope of direct common tangent. If one point is given to us and we are taking slope m, then what is the equation of direct common tangent? So the equation of direct common tangent is, this is one point and one slope is given, then this is the equation, y minus y1 is equal to m into x minus x1. This is your x1 and this is your y1 for the equation of direct common tangent. So y minus y1, what is y1? minus 4, minus into minus plus 4 is equal to m. We do not have any value for the m, keep it as it is, x minus x1, that is minus, as it is on the place of x1 is 22. Okay, just simplifying it, y plus 4 is equal to mx minus 22m. Shift these things. This implies mx minus y, keep x positive, minus y, and then minus 22m minus 4 is equal to 0. Okay, this is our equation first. Okay, just I'm making a box. This also you can make a box, we are going to use afterwards. If you want to name this as, this is A. Okay, now see here, mx minus y minus 22m minus 4 is equal to 0. It is the equation of tangent to the circle. If, listen, what happened if this is the equation of tangent? This is, I'm asking about this. Okay, this is a distance, perpendicular distance. You can, this is the point of contact, this is the radius. If you want to keep the name, this as d. Okay, this is the called as perpendicular distance. Okay, so if, look at here, if equation 1 is the equation of tangent to the circle S2. I'm taking the, this is the first circle, radius big, this is the another circle. That circle I am taking. S2 is equal to 0. Okay, if the equation 1 is the equation of tangent to the circle S2 is equal to 0, then what happened? Then the perpendicular distance is should be equal to radius. The D is the perpendicular distance from the center, that is the perpendicular distance of C2, that is center 2. Okay, it should be equal to the radius. From point of contact to this center is called as radius. So this condition should be satisfied if we are using here d is equal to 2. Okay, as we are using S2, if we are using S2 circle secant, so we have to take center 2 for the next calculation purpose. That is, we know that the perpendicular distance formula, okay, d is equal to perpendicular distance from center C2. What is the value of C2? What we have got, anyone know what is the value of C2 we have got? Just I have erased here. What was the value of C2? C2 value I want. Anyone? 11 comma minus 2, I think. Yes, I have seen the question here. 11 comma minus 2. Is it right? Those who are listening? Yes? Yes, anyone? Okay. C2, 11 comma minus 2. Using the formula of perpendicular distance and equating to that with the radius. Okay. Mod ax1 plus by1 plus c divided by root over a square plus b square should be equal to r2. That is, radius is here for us is r2. On the place of r, I'm using r2 at it is radius. So a is m. X1. What is x1? 11. Ax1 plus by1. What is b? -2. Y1 is -1. So it will be +2. Minus into minus plus. Plus c. C is this complete constant term. -22m -4. -22m -4. Divided by root over a square plus b square. A square is m square, b square is -1 square is 1. Directly I am writing m square plus 1. Mod close R2 is, that is radius 2 is 5. So simplify the numerator here. What we are getting? 11m plus 2 minus 22m minus 4 divided by root over, just writing in a proper way, is equal to 5. So 11m minus 22m is minus 11m, minus 4 plus 2 is minus 2 divided by root over 1 plus m square is equal to 5. Okay, just take minus common in the numerator. If you take minus common, 11m plus 2, send it to that side. 5 in the bracket root over 1 plus m square. Okay. Now, in order to find the value of m, we need to get to find the factor. So we need to do squaring on both sides. So squaring on both sides, what we are getting, remove the mod, not an issue. If you want to remove the minus, then also not an issue. Minus 11m plus 2 whole square. 5 square is 25. Root and square get cancelled. You will get 1 plus m square. Here minus square is plus. Now this is a plus b whole square. We need to get some values, I think, from here. This time referring. Okay. Should equal to should come. Okay. Now a plus b whole square. This minus square is plus a plus b whole square. What is that? A square, that is 11m square plus 2ab, that is 11m a into b, that is 2, plus b square, that is 2 square, is equal to 25 into 1, 25, plus 25 into m square is 25m square. Now, simplifying it, 11 square is 121 m square. Bring this 25 m square to LHS, it will become minus 25 m square plus 2 11 the 22, 22 to the 44 m. Okay, plus 2 square is 4 plus 25 comes here, it will become minus 25 is equal to 0. Okay, so what we can simplify here? 121 m square minus 25 m square is how much? Anyone? 96 m square plus 44 m minus 21 is equal to 0. Again, this is a quadratic equation in m variable. In order to find the values of m, we need to do factorization. I hope you know the concept behind the factorization. 96 into minus 21, you will get 2016, I think, minus 2016. So the middle term, we have to split into two terms that give us minus 20. When we add, we should get middle term. When we multiply the coefficients, we should get minus 2016. Okay, that was the concept. Look at here. 96 m square. This plus 44m, I am writing 72m minus 28m. 72m minus 28m, it is 44m. Okay. And 72 into minus 28, you will get the same 96 into minus 21. That was the concept, remember. Minus 21 is equal to 0. Now, from these two terms, if I take 24m common, what I'm taking 24m, I'm taking common. What I will get, that is, I think here 4m plus 3. 24, 3 the 72 m as it is. Yeah. Now here, what we can take common? If I take minus 7 common, 7 4 the 28 m as it is, plus 7 3 the 21 is equal to 0. So we have got two things, 4m plus 3 and 24m minus 7. So write it here, 4m plus 3 common. So remaining term is 24m minus 7 is equal to 0. Now equate this with 0 separately. So 4m plus 3 is equal to 0. 4m is equal to minus 3. M is equal to minus 3 by 4. One value we have got. Another one, comma, 24m minus 7 is equal to 0. So 24m is equal to 7. M is equal to 7 by 24. This another two values we have got. Now, equation of direct tangent is very near to find now. By using equation A, we are having two cases. One case is minus 3 by 4, another case is 7 by 24. Then we will get equation of direct common tangent. Okay. So what we are having, if m is equal to minus 3 by 4, from equation A, what we are having, y plus 4 is equal to m into x minus 22. So simplify it. On the place of m, we should keep minus 3 by 4. So y plus 4 is equal to minus 3 by 4 x minus 22. Just multiply these 4 with these complete terms. So what we are getting? Four y plus 16 is equal to minus 3x minus into minus plus 66. Simplify it. Bring this to these terms this side. So 3x plus 4y plus 16 minus 66 is equal to 0. So 3x plus 4y minus 50 is equal to 0. This is the one equation of direct common tangents we have got. No need to. Okay. Next, case second. If m is equal to 7 by 24, from equation A, same equation A, that is y plus 4 is equal to m, on the place of m 7 by 24, x minus 22. Okay, right? Equation A, yeah, x minus 22. Multiply 24 into y, 24y plus 24 into 4, 96 is equal to 7 into x, 7x minus 7 to the 14, carry 1, 7 to the 14 plus 1, 15 minus 154. Okay, send these terms to that side. Keep x positive. So this implies 7x minus 24y minus 154 minus 96 is equal to 0. So this we can write 7x minus 24y. Add this to what we are getting, 100, 250 minus 250 is equal to 0. Okay. Therefore, the equations of direct common tangent, the required equation of direct common tangents are the required equations of direct common tangents are first is 3x plus 4y minus 50 is equal to 0 and 7x minus 24y minus 250 is equal to 0. This is the solution for the direct common tangents problem. Any problem that is asking direct common tangents depends on the steps. See, finding C1, R1, C2, R2, C1, C2, R1 plus R2. These are the general common steps. All everywhere it is going to use if this step in this type of questions. Okay, then on the condition of point of similitude, section formula internally or externally. This is the difference, and again remaining same. Okay, so once again go through the problem from the beginning. If you have any doubt, please clarify. And then I'm going to give you homework. One problem ends homework. Check it once again. Please ask if I have any doubt. If you do not have any doubt, then one problem I'm giving as homework. Please do it. And these are the most expected problem that will come on the position question number 19 of your exams. Okay. Shall I rough it? Yeah. Find the transverse common tangents of the circles x square plus y square minus 4x minus 10y plus 28 is equal to 0, and x square plus y square plus 4x, x square plus y square plus 4x minus 6y plus 4 is equal to 0. See here, transverse common tangents. Okay, just I'm little bit drawing I'm doing here. If this is one circle, this is another circle, this is the point of similitude. Okay, this is the transfer common tangent, and this is, okay, these are the common transfer common tangents. Okay. Finding C1 R1, C2 R2, C1 C2 R1 plus R2 are the common steps. But when it's come to the point of similitude, internal formula, section internal formula you have to use, and again remaining the same concept you have to follow. Just one thing, in the previous problem, point of similitude here, point of similitude here. So you have to use internal section formula. Okay, remaining all the concept is same. So hope these things are helpful for you to understand circles, LAQs. These are the most important LAQs of the circles that we have done till today. Okay. Hopefully, we are going to use another chapter for the next LAQs. Okay.